This video is on conjugate acid-base pairs, and we define conjugate, and if you look it up, is different forms of the same thing. And we can talk about conjugate verbs, for example, say and said, which mean the same thing, it's just the tense, okay? So in a conjugate acid-base pair, we're going to give you a reaction. And if I go HF plus H2O reacts, and this is a weak acid, so you should be able to predict this, but I'm not asking you to predict in this learning objective. And I'm probably going to start dropping my aqueouses and liquids, but you should know they're there. In this, you're going to look at the reaction to identify what is the acid and what is the base. And remember, an acid is a proton donor, and a base is a proton acceptor. So in this reaction, what we do is look at which one lost and which one gained a proton, and it's pretty obvious that HF lost a proton, so it is the acid, it donated it, and water in this case is the base because it accepted a proton. Now if I write the reaction backwards, which I can write these backwards, F minus plus H3O plus yields HF plus H2O. In this case, the F minus was the base because it accepted a proton from the H3O plus, which was the acid. You know it did this because when you look at the other side, the F minus became HF and the H3O plus became H2O. Same up here, HF became F minus on the top reaction, and H2O became H3O plus. So the only way that can happen is if a proton transfers from the HF to the H2O or the H3O plus to the F minus. A proton transfers from the H3O plus to the F minus. But we don't write them backwards. We do this instead. We go HF plus H2O and a double arrow because it's a weak acid, but you don't have to worry about it. F minus plus H3O plus, and we say this is an acid and this is the base, but if it goes backwards like we just showed, this is the acid, the H3O plus, and this is the base. So these are conjugates. The HF is a conjugate of F minus. It's the same thing in a slightly different form. This is the acid form over here, and F minus is the base form. And then we have the conjugate here. I've drawn it in green so you don't get mixed up. And in this case, water is the base, and H3O plus is its conjugate acid. It's the same compound in a different form. Okay, that's all it is. Just a couple examples here. And you don't have to write these reactions. You just have to be able to identify what the conjugate acid-base pairs are. Okay, and so on this side, you just look at the reaction, and HF clearly, to become F minus, had to give up a proton, so it is the acid, and Cn minus must be the base. And on the other side, it's just going to be exactly opposite. The F minus gained a proton from the HCN on the right side, so the F minus is the base, and the HCN will be the acid. Now these are, to show me this, you just connect them. And I'm going to connect them with different colors. Actually, I'm going to connect them with black to show you. I'll do this twice to show you what not to do. This is the base, this is the acid, and here it is with a different color, acid base. Same compound, same element, different form. What I don't want to see on an exam, if I give you paper exams, is this, because I can't tell which one goes with which. So you have to make it clear on the exam. They don't have to be in color. They can cross. Just don't put your lines together. In fact, let's erase it because that's awful. All right, and another example, CH3, COOH plus NH3. That gives us CH3, COO minus plus NH4 plus. And find the conjugate acid bases. This is the acid. This is the base, and this is the acid over here, and this is the base. How I figure that is I go here for the acid. I note that CH3COOH became CH3COO minus on this side, and NH3 became NH4 plus. That's one way to look at it. So the only way it could do that was to transfer the proton. Now one more thing, H2O plus H2O reacts to form H3O plus OH minus. In this one, I don't know which one goes with which. I know that this is the acid over here, H3O plus, because it becomes water, and this is the base because it accepts a proton from the H3O. And so I can write any one of these, H2O going to H3O, H2O going to H3O. This is the acid, this is the base, and then OH going to H2O minus. This is the base, this is the acid. And those are conjugate base pairs. This is called autoionization. And lots of things can do it. We'll only deal with the autoionization of water, but things like HF, if in extreme conditions, can also do this. And you may see some of these, F minus plus H2F plus, very unusual. I'll just show you another example of autoionization. This is the acid, this is the base. Okay, so that's it. Do the homework. I have a bunch in there on that.